Hello friends, welcome to today's lecture Influence Line Diagram, that is ILD. Myself, Mr. Y.S. Patil, Department of Civil Engineering, State Institute of Technology, College of Engineering, Yadrao. So in this lecture, we solve or we draw the ILD for a compound beam. Compound beam means there are two beams connected with each other. So draw ILD for RA, RB, MA, shear force at D, bending moment at D. So this is a given beam A, C, B. At C point there is hinge and at B point is a simple support and at A is a fixed support. So AD is a 4 meter, CD is a 2 meter and BC is a 4 meter. So first of all we draw ILD for RA, RB and MA. Basically due to this hinge means it is a support or it is a point, means is separate that AC beam and CB beam. This is the AC and this is the CB. Means CB is a simply supported beam, supported at C and supported at B. And due to this RC, whatever the RC reaction comes on that beam AC, that is at the free end, and A is a fixed support. So whatever the load on that AC is taken by the support A. So let us see, first of all draw ILD for RB. This is the RB point. Means suppose load lies between A to C. Load lies between A to C. There is no reaction for RB because this is a separate beam. See here, when load lies between A to C, whatever the load acting on the A to C, the reaction generated at point A only. There is no reaction at B. So when load lies between A to C, there is no reaction at B. Then suppose when unit load is on RHS of C. RHS means right hand side of C at a distance of X. See here, at a distance of X from point C. So I want to find out RB. Then taking moment about C. Then 1 kilonewton, this is a clockwise moment and RB is an anti-clockwise moment. So 1 into X is equal to RB into 4. So RB is equal to X by 4. This condition is only satisfied or this condition is only valid when the load lies between C to B. So put up X value when and X is measures from point C. So X is equal to 0 means load on at point C. RB value will be 0. Then load moves to C point to B point. Then X is equal to 4. Then RB value will be 1. Means suppose RB is equal to X by 4. We know that summation Fy is equal to 0. Upward forces in the system is 2, RC and RB, and downward is 1. So RB plus RC is equal to 1. Then RC is equal to 1 minus RB is there. RC is equal to 1 minus RB, and RC, this is a separate beam, that beam BC, and this is the beam AC. Whatever the reaction RC comes in beam BC, that reaction acted on beam AC in opposite direction. Means if RC going in upward direction for beam CB, then the RC apply downward direction for beam AC. So RA value or when that RC in this equation or in this beam, this is a fixed support RA. So whatever the load on this beam A to C, the total load taken by only support A. So RA is equal to RC is equal to 1 minus X by 4, that is 1 minus RB. Now put up or draw this sketch ILD. Means basically when load lies between A to C, there is no reaction or there is no reaction at B. So it becomes 0. Then next when load acting at point C, it become 0, and when load acting at point B, its value will be 1, and both values are positive. So plot upside and join this. This is the ILD for RB. Then next, draw ILD for RA. Now similarly, same concept, when unit load acting on RHS of C at a distance of x from point C, this is the RB value, and RC value is 1 minus RB, and that RC value is equal to RA value. So 0 to 1, this is the same as per that RB. Okay, then next, put up C is equal to 0. C is equal to 0. The RA value will be 1, means load acting at point C. So this is the C point. So 1 kilonewton RC, and that 1 kilonewton RC acting on that AC beam is vertically downward 1. So, and A is a fixed support. So whatever the load on beam AC, total load carried by the support A. So C is equal to 0, RA is equal to 1. Then C is equal to 4, RA becomes 0. This is part C to B. Now load comes in between A to C. Whatever the total load come on A to C beam or span, the total load carried by the only support A. So when load lies between A to C, the reaction A at will be 1. So draw A to C is equal to 1, at point C 1, and at point B 0. This is the ILD for RA. Then next, ILD for MA. First, consider when load is on RHS of C at a distance of x from point C, means load lies between C to B. Now I want to draw moment for MA. So first, load lies this is the x, this is the unit load 1. So I want to taking moment about A. First, RB into 10 minus 1, this is the unit load, and 6 plus x, means that AC distance is 6 plus this x. So MA is equal to RB into 10 minus 1 in bracket 6 plus x. By simplifying this equation, we got MA is equal to 3x divided by 2 minus 6. This is the MA. And this condition is only valid when load on the RHS of C, means this is the condition. So put x is equal to 0, means exact point C, that x is equal to 0, the MA value will be minus 6. Then next, consider x is equal to, or that unit load moves up to point B, that x is equal to 4, then MA will be 0. This is our first condition. Then second, when load lies on LHS, means left side of C. I randomly, this is a 1 kilonewton, and at a distance of x, this is unit load. Now RA becomes 1 because this is a separate beam. AC is a separate beam, cantilever beam. So whatever the load on beam AC, reaction will be 1. So MA is equal to 1 into distance. This is the total distance is 6, and this is C2, this point load distance is x. So 6 minus x, and direction of the moment is clockwise, right side clockwise, consider minus. So MA is equal to minus 1 into 6 minus x. Now put up values. X is equal to, means bus first that point load acting at point C, so X becomes 0 and that answer will be minus 6. Then this load comes at point A, X becomes now 6 and MA value will be 0. So this is a table from considering RHS side, from considering LHS side. At point C, MA will be 6, that minus 6, minus value plot downside. At point B, it becomes 0. Then by considering RHS, at point C, it becomes minus 6, means at same point. And at point A, 0. So this is the 0. Join the coordinates, that is 0, 6, 0. This is the ILD for MA. Then next, ILD for shear force at D. So first, once again, consider when load is on RHS of C, means in this span at a distance of X from point C. So shear force value is RC, because consider shear force at D. I want to consider shear force at D. So consider right side, and this is the AC portion. So the number of forces on the right side is RC, and that is vertically downward. This is our cantilever beam, and this is the RC. Whatever the reactions come due to this unit load at RC, apply that RC load on this particular AC beam and consider right side. So RC become 1 minus X by 4. X by 4 is nothing but RB, that is RC is equal to 1 minus RB, already seen in first condition. So point C, X is equal to 0, SF at D is equal to 1. Then X is equal to 4, SF at D is equal to 0. Then next, when load on the LHS of C, means load now comes in this way at point C at a distance of X from point C and less than 2 meter. So number of forces on the right side, that is 1, and this is a 1 kilonewton. So SF at D is equal to 1. When load crosses that D point, means LHS of D, means this load moves up to or crosses that D point. Now we consider, means at the left side there are two forces. First one is that unit load and second one is a RA. So number of forces on the left side is 2 and number of forces on the right side is 0. So we consider right side. So SF at D, when load on the LHS of D, the value is 0. So by using this coordinate, draw ILD. First, shear force at C, shear force at D, when load at C, it become 1. When load at B, shear force at D is 0. Then when load on the LHS of C and at a distance of X from point C and less than 2 meter, means this load up to point D, so SF at D will be 1. And when load crosses going on the LHS side of that D point, the shear force value will be 0. So join all points. This is the ILD for shear force at D. Then next, ILD for bending moment at D. First, once again, unit load is on RHS of C, means this is a condition. This is the unit load 1 at a distance of X from point C. So bending moment at D is equal to, I want to bending moment at D is equal to RB into 6. RB into 6, this is 4 into 4 plus 2, that is 6, minus 1 1, this is unit load, into 2 plus x, this is the 2 and plus x. In this condition RC is not considered because upward force RC and downward force RC cancel with each other, so only consider RB and unit load. So RB is x by 4, so 6x by 4 minus 2x minus 2. So simplifying this equation, bending moment at D is equal to x by 2 minus 2, and this equation is only when load acting RHS of C. So bending moment at D, when C is equal to 0, the value becomes minus 2, and x is equal to 4 means that load moves up to point B, the value becomes 0. Then next, when unit load lies on the LHS of C, means in between span A to C at a distance of x from point C, and it is less than 2 meter, means that load lies between only C to D. This is a 1 kilonewton at a distance of x from point C. So bending moment at D is equal to, I want to bending moment at D is equal to 1 into, this is the x and this is the 2. So remaining distance is, this distance is 2 minus x. So minus 1 into 2 minus x. So when load at point C, x becomes 0. So answer will be minus 2. And load comes at point D, the x become 2 and bending moment at D is equal to 0. And when load crosses that D point, load crosses that the D point, so consider only right side and there is no load, so bending moment at D is 0, means when load lies between A to D, the bending moment value at D is equal to 0. So this is the coordinates when load on the RHS of C, and this is the load on LHS of C and in between D. So at C point, x is equal to 0, that value will be minus 2. Minus value plot downside of the baseline, this is the 2. At B it becomes 0. At C minus 2. For bending moment common point, C is a common point for both conditions, so that value for bending moment is same, minus 2 minus 2. And at point D it will be 0 and at A 0. So this is the baseline. So join all the coordinates and this is the ILD for bending moment at D. Once again I repeat, whenever the common points are there, the bending moment value is same for that common point. In this condition, C is a common point for both cases, and that bending moment value is minus 2 in both cases. This is a simple check, whatever our calculation is right or wrong. Thank you.